Hello and welcome to this Level 3 Mathematics in Context training video for Pearson and Excel. This video is about combined probability events. Here's a specification reference. So we're looking at calculating the probability of independent and dependent combined events, including sampling with or without replacement using tree diagrams and other representations such as Venn diagrams. There are no relevant formulae available in the formula book for this topic. Here's the mapping from GCSE and GCE to Maths in Context. You can see this topic appears a lot at GCSE Maths, Statistics and in A-Level Mathematics. So here's some ideas how we can teach it. Students could create some Venn diagrams about the common subjects they study, or some other topics as well. They could also investigate probabilities of winning simple games involving dinosaur spinners, form tree diagrams relating to playing one game after another. The key skills needed for this topic. Students should be able to complete and read from sample size diagrams and two-way tables. They need to know set notation and be able to apply it to probability situations. They also need to be able to find probabilities from Venn diagrams and tree diagrams. So here's an exam question from 2017, paper 2, question 7. In a factory, machines A, B and C make identical belts. Some of the belts are defective. The Venn diagram shows information about the belts. Students have to describe in context A intersect D, have to explain why the probability of A intersect B is 0, and have to describe in context what the shady region represents. So in context, A intersect D, D is a set of defective belts, A is the set of belts made by machine A, so A intersect D represents the defective belts that come from machine A. To explain why probability of A intersect B equals 0, set A represents the belts made by machine A, and set B represents the belts made by machine B. A belt cannot be made by both machine A and machine B, therefore the probability of the intersection between A and B will be 0. You can see on the Venn diagram, the sets do not intersect. Part 3, describe in context what the shady region represents. So the shady region there is the area which is not in set A and not in set B, therefore it will be belt made by machine C, and it is inside set D, so the shady region represents the defective belt made by machine C. Here's the mark scheme. The exam report suggested that describing the regions within the context of the scenario proved difficult. Students again just quoted theoretical reasons why A intersect B was equal to 0, using words such as mutually exclusive, rather than applying to the situation in the diagram. Students did fail to read the question carefully for part 3. So here's another exam question from 2017, paper 2, question 8. Again, it regards the belts made by machines A, B and C. The number of belts made by machines A, B and C in the ratio 2 to 1 to 3. The proportion of defective belts made by machines A, B and C is 0.02, 0.03, 0.025 respectively. All the belts made are put in a storeroom. Part A, we need to work out the probability that a belt selected at random from the storeroom is defective. Then we have a batch of 115 belts is made by machine A. Probability that a belt made by machine A is defective is 0.02. Part B, show that the probability that this batch contains at least one defective belt is greater than 0.9. Here's the answer to part A. We can draw a tree diagram for this situation. We've got the first set of branches showing the probabilities of the belts made by machine A, B and C, changing those ratio to 1, 3 into fractions out of 6. And the second sets are defective and not defective. We want the probability of the belt selected at random is defective. So you can see we want to use 2/6 times 0.02, 1/6 times 0.03, 3/6 times 0.025. Adding those together gives us an answer of 29 out of 1,200. For part B, the probability that at least one defective will be the probability that not all belts are not defective. So for this we can do 1 minus the probability of all not defective, which will be 1 minus 0.98 to the power of 115. This gives us a result greater than 0.9. Here's the mark scheme. The exam report suggested it was a demanding question for probability. It was not done well by moderate students. Students who opted to use fractions were inaccurate when converting to decimal equivalents. Things like stating that 1/3 was 0.3 or 0.33. This will lead to inaccurate calculations. Only a handful of students scored 4 marks on Part B. So top tips. Students should ensure they can complete Venn diagrams with 2 and 3 sets. They should practice drawing tree diagrams to help them calculate probabilities of combined events. They should also ensure they understand the set notation used in probability. Thank you for listening to this video. I hope you found it useful.